Started just a few words here at the start as an introduction. We didn't at the very beginning of NeuroHackademy say much about the Science Institute here at the UW, but it's actually a very special place. So Noah and I work at the Science Institute. It's sort of the Center for Data Science at UW. And that means that people who work at eScience come from a variety of different research fields and all work on things like software and data and everything that you've seen over in NeuroHackademy. And interact with people all over the university and with stakeholders outside the university to do data science more broadly. One of the extensions of eScience in the last year or so has been the Scientific Software Engineering Center that was recently funded. This is within eScience, a particular center that focuses on software engineering more specifically. The strategy there is to recruit software engineers with lots of experience doing software engineering across a variety of contexts, and then work with researchers, again, a variety of different fields to build really good software to do research. And Vani Mandava, who's the head of engineering of the SSEEK, is here today to tell us about the process and project management in software engineering. I'll let her take it away.
Thank you for that introduction, Ariel. Hi, everyone. I'm happy to be here and I thank you for your time today. I sent a poll out on Friday asking if people would want a hands-on tutorial or a lecture style talk. And there were 3 people who responded to the poll. Thank you if you're here. I was expecting 3 people to come to this talk, so it's really great to see such a great turnout. 2 people said lecture style and 1 person said hands-on, so we're going to go with lecture style. But before I begin, I want you each to just reflect and write down on your computers or on a piece of paper what you expect to get out of this lecture today. Just take a minute to think about it and write it down. Okay, is most of you done? Yes? So through the course of this lecture, keep that in mind and please ask questions. 90 minutes is a long time. I am not a professor, I'm an engineer. This is not what I do every day, so I don't want you dozing off and I want to make sure that it's a good use of your time if you're going to be spending 90 minutes here. Let's try and make it interactive. Ask questions as we go along. There'll be plenty of time for questions at the end as well. So a little bit about myself. Let me find my mouse. Okay, there it is. Yeah, and thank you also to the folks who've joined on Zoom. Is someone monitoring the Zoom chat? Okay, good. So I am a computer scientist by training. I am currently, as Ariel said, the head of engineering at the Scientific Software Engineering Center at the eScience Institute. I took this role less than a year ago in September of last year. Before that, I spent 22 years working at Microsoft, of which I spent 12 years working in product development and 10 years working at Microsoft Research. Listed on the slide are some of the products that I worked on in my time there. It was really a great experience working on client software, server software, and then as Microsoft made the transition from traditional boxed software to online services, I was very much on the ground floor of that transition. So it was really exciting to work on some of these projects. My last role at Microsoft before I took on this job was the director of data science at Microsoft Research. And I worked on a lot of research collaborations with academics, which is what attracted me to working in academia. And I'm having a blast. It's been a really amazing place to work at the University of Washington. The Scientific Software Engineering Center was created via a grant given by Schmidt Futures. They started 4 centers, one here at UW, one in Georgia Tech, one in Johns Hopkins, and one in University of Cambridge, under this effort that they call Virtual Institute for Scientific Software. And the goal is to leverage industry-grade software engineering practices in the development of scientific software in academia, because software that gets built in academia isn't often sustainable. So the hypothesis is if we apply mature and time-tested software engineering or software development practice to the software, can we make it more robust and sustainable over time? So that remains to be seen. So far, I think we've been having some moderate success with that vision. This is the outline of my talk. I'll talk a little bit about the motivation. I'll talk about product planning. I'll talk about SDLC, software development lifecycle. Just show of hands, has anyone worked like in a traditional SDLC team in the past? Okay, that's great. So I will not be, telling you about something that you already know. That's good. We'll talk about some agile development tools. I'll talk about some examples from the center based on the work that we've been doing over the last 6 to 8 months. And I'll leave plenty of time at the end for Q&A. So what is common between these 2 pictures? The picture on the left is the Mars rover landing, and the picture on the right is the development of the COVID-19 vaccine. What's common between these 2? Well, it's in the title of the talk. Yes?
A lot of money.
Yeah, that's great motivation. Yeah, and money put in. What is the common component into both of these breakthroughs?
Engineering.
Yes, software engineering. That's right. Software is behind everything that we see now, and it has been for many, many years, maybe even decades, maybe centuries. It's not always obvious to us, but there's a lot of software that gets written for great scientific and technological breakthroughs. In scientific software, it's an even bigger need to establish really good software development practices, because there is something called a reproducibility crisis in scientific software. We need to make scientific software development better in order to make better scientific software. And I'll get into what that means in a minute. This was, if any one of you has been following the reproducibility crisis, or if you've been around this stuff, reproducibility is an area in itself that is studied by many researchers. Nature did a survey of 1,500 some researchers several years ago. And the question they asked was, is there a reproducibility crisis? And over half the respondents said, yes, there is a reproducibility crisis. There were several reasons that were stated for that crisis. And the important part here is that most of these surveyed researchers were in the computational sciences, not in computer science. One of the favorite quotes that I like, I don't know who the original author of this quote is that computer scientists work on yesterday's problems with tomorrow's tools, and computational scientists work on tomorrow's problems with yesterday's tools. And the reason for that is there's just not enough investment in good software engineering in the computational scientists. So these were people in biology, physics, chemistry, medicine, and so on. So yes, there is a crisis. And there's several reasons for it. Software, lack of good software engineering practices is a significant reason for this. Here's another one, which is a bit more technical for the ones who are interested. There's a the paper that this is from is listed on the slide. This paper was published, I think, in AAAI about 5 years ago. It was an analysis based on a survey of 400 AI papers. As we all know, we are going through this very big, moment in history with the proliferation of generative AI tools, large language model breakthroughs. And the research here was about what exactly is going on with with the reproducibility of AI research. And the three different axes were experiment reproducible, data reproducible, and method reproducible. The results of an experiment are experiment reproducible when the execution of the same implementation of an AI method produces the same results when executed on the same data. Data reproducible is when an experiment is conducted that executes an alternative implementation of the AI method that produces the same results on the same data. And method reproducible is when the alternative implementation of the AI method produces the same results when executed on different data. So it's kind of a bit of a matrix there. But then they had 24 other metrics against which they determined if the AI published in these papers were reproducible or not. One of the remarkable findings of this research was that only 6% of these papers actually had their code available and published. So even though many of these papers were in the so-called open science domain, they were just not reproducible because the code just wasn't available. So this is a real crisis if we were to continue to pursue AI research in the open science sphere. So I want to change the title of our talk today a little bit and not talk about project management, but talk about product management, okay? The reason for that is it is important to look at software development as the creation of a product and not just as a project. This is the main sort of difference that I have noticed in my job here in academia as compared to how software is built in industry. In industry, software is always built with the goal of a product at the end of that, a product that fits a certain market, behind which a business can be built, behind which there can be huge commercial success. That's not what we are doing in academia. However, applying that same mindset of product development is going to help us achieve some of the successes that tech industry has seen as far as software development is concerned. So in these two pictures, can someone tell me which one is a project and which one is a product?
One is a project.
Sorry? That's correct. The picture on the left is a project and the picture on the right is a product. That's one way of looking at the difference between the two, right? Set of ingredients, perhaps a recipe, maybe a process on how it's all going to be put together is a project. The one on the right is a product. If you think about the product in mind from the onset, you also think about the customer or the user or the client. In your case, it's likely scientists and these kind of people. I can tell you if the product in mind is the one on the right, I know that my kid is not going to consume that product, right? So I'll be very mindful of the process. I'll be mindful of the ingredients and I'll be mindful of what that end user, what that customer looks like. Or what that customer is likely to use or buy or adopt when I think about product development. One of the key ingredients of a good product development plan is a roadmap or a product plan. It's a long-term plan to give all stakeholders the information they need to plan and coordinate activities, and it brings predictability to the product development process. It's very important to think about that product plan as you embark on your project or as you embark on your software project. I know that you are heading into hackathons over the next few days. think about that product plan approach. And this is not something that is necessarily important for, a multi-month or multi-year software development effort. You can also apply this in the small in a hackathon setting. So through the rest of my talk, I'm going to go over many different terms and tools and processes. Think of it like a bit of a toolbox. Some of it is going to be useful to you. Some of it might not be useful quite yet. That's okay. See what you can use, see what applies to you in the context of the hackathon that you're about to do over the next few days. I'm going to pause here. I've been talking for a bit. Are there any questions so far? Okay, clear? Everything's clear so far? Okay. So this is a quote from a professor. Okay, a field is said to have lost its way when it forgets who the customer is. This is especially true in scientific research because most scientists, most people who are working, especially on building software in academia, are very deep in the areas that they work on, as it should be. However, if all you focus on is the problem, a problem that you likely started looking at several years ago, you have to constantly think about how that problem is still relevant in today's world, in what is available today, in what is important to the users for who you're solving that problem. You have to have relentless pursuit of that end customer, of those end users. And that customer aspect is still important, even though it is scientific research. We talked about stakeholders. We talked about why a product plan is important, and that it gives visibility to stakeholders. Who are these stakeholders? They are customers. So those are like scientists and users. They are customer-facing groups. So not directly the scientists, but it could be the students that are attending, courses that these scientists are creating. They're executive sponsors. So if you're working on research that is coming from a funding agency, then that is a stakeholder. They are the engineers. The engineers are actually going to design and build the solution. And they are the admin team, so the contract managers and so on. Here's an example from one of our projects that the SC Center is working on. This is a project called Neglected Diagnostics. You can read about it on our website if you go to eScience and Scientific Software Engineering Center. It's software that will enable researchers to rapidly create genetic tests for use in the field. And this group, this was actually from a PI and their research group, they did a really nice job of identifying who their customer, who their user was going to be. And look at how long that list is. It's the list of personas or users that are highlighted in blue on the slide. If you were to keep every single one of those in mind at the onset, then you are going to be more successful in the creation of your software, because you're going to ensure that your software requirements takes into account every single one of those personas before you start building the software. So even your architectural decisions, the design of the software is going to be mindful of it being helpful to every single one of those user groups. In terms of building that product plan, what does that look like? What tools can you use? It honestly does not matter. It could just be back of the napkin, something that you just draw up on the whiteboard along with your colleagues. It could be a slide deck with a detailed strategy and feature breakdown. It could be a list. Or you could use more sophisticated product management software tools. And we'll go over some of those a little bit later in the talk. You might have seen this image. It's a fairly common image. There's many variations of this on the internet. But it basically takes you through product development, how it actually happens in IT, even though, like I told you all this stuff, oh, industry's got this figured out. That's not really true. I mean, there's been a lot of evolution, but at the end of the day, there's still a ton of commercial software that gets built and thrown away. And the reason for that is what customers expect and what actually gets built is very different. And it's different for many, many reasons. A big part of the reason is lack of stakeholder alignment. If every stakeholder listed in this cartoon was aligned every step of the way, then it is less likely going to fail. Can anyone identify with this? Has this happened to any of your projects? Yeah, you are smiling. Yeah, I like the disaster recovery plan. Oftentimes there is none, right? Which is why you see these sometimes in the news, some of the big company servers going down now with everyone on the cloud. Entire services that you did not even realize relied on a cloud strategy has gone down. Websites are down. There's a lot of security issues. This kind of illustration is used a lot actually in building of secure software, because there it actually matters. You can end up having very huge business losses because of security bugs in your software. So what is the success criteria of a good product plan? It needs to have a sound strategy. There has to be a strategic alignment behind it. It has to be realistic. It has to be fully aligned and supported by the stakeholders. And oftentimes, I fall in this trap often, like when Ariel said, hey, can you give us a talk on project management? I'm like, it's not something you talk about, it's just something you do, right? And over the years, I have built some intuition on how to manage a software development team. That's not enough because it doesn't scale. Even if you have some intuition, if you're working with others in your group who you're trying to influence in following your intuition, it's not enough. It has to be channeled into a process. And there's lots and lots of tools and processes out there. You just have to pick one and channel your intuition into that process such that you can build that alignment. And that customer knowledge is the primary currency of a good product plan. Let's talk a little bit about product market fit, right? There's two products in this graph. Product market fit is the degree to which the same product satisfies many customers with the same need. Okay, so product A is the one in blue and product B is the one in green. Product A has product market fit. So after it has some initial adoption, and I'll go into the different types of adoption in the next slide. But you can see that product A is mostly successful versus product B. It gets some adoption at the beginning, but it does not have good product market fit. So eventually the percentage of active users just dwindles down. How many times have you done that? Like someone tells you, hey, look, check out this new tool I'm using, right? The engineers in SC are doing this all the time. Every day, they're showing me a new productivity tool. There's so many of them coming out. You know, almost every week, there's a new tool that comes out. You try it out. If it doesn't stick, you stop using it. And the percent active users eventually just, dwindles down to zero. This is a very old theory from social sciences called diffusion of innovation, where all of the users of a product can be categorized as either innovators, early adopters, the early majority, the late majority, or the laggards, right? So this blue line shows the different categories that these user types fall in, and the yellow line is basically how it gets to that 100% market share. Somewhere over here, yeah, I'm sorry, my mouse is on my somewhere over here is the tipping point that determines whether or not a product will succeed or fail. If your product can sustain past the early adopters into the early majority, then you're likely going to have success with it. You'll also hear of some images of this if you look for diffusion of innovation. It's called a trench. So a lot of times a product will just fall down the trench over here. There's a whole book written about the tipping point that was very popular a few years ago. The title of the book is The Tipping Point. And then another way of looking about product development is there's two stages under which you have to consider your product development. One is an early stage product, which has unmet customer needs, and you have a lot of freedom and flexibility to try out various hypotheses and test it out in the market, depending on what kind of resourcing and funding you have to be able to do this. There's A/B experimentation. There's all kinds of things you can do. And then there's the late stage, which is once product market fit is achieved and you have active engaged customers, how you invest in the product. At that point, you cannot make a big change in the product. But you need to watch carefully how users are using the product and how you can continue to grow that user base for the product. Any questions so far? Can you see how this is applicable to the kind of work that you're doing, or this is just too far, like distant? This is how industry does it. How does it even apply? Any thoughts on that? Where does your work mostly fall? Does it fall in the early stage or the late stage? Yeah, most scientific research projects do fall under the early stage, which is honestly a luxury. It's incredibly exciting to work on early stage products. And I, through my career, have had the luck to work on many V1 products, which is super fun because you get to create something where nothing exists. You get to innovate and you get to see how it will be used. Yes.
I have a question in terms of product. Is very different in science as opposed to a company that has employees and they stay in the company. Whereas in scientific groups, there is like maybe someone that developed a certain software that then decides to leave for another group or some other position, and then does not continue the development and maintenance of the software. So I don't know if you're going to go into those details, but I think that's for doing something important to take in terms of software management.
Yeah. Thanks. Your name?
Eric,
yeah, thanks for the question, Eric. I'll just repeat it for the folks on Zoom. The question was about sustainability of software. Oftentimes in research, someone builds software and when they leave, there really isn't a clear ownership or path for the software to be maintained beyond, a certain time. And that often results in, that software not being successful in terms of adoption, right? Is that, could you characterize that?
well, the adoption does not take place because there's no.
Correct. Yeah. No, that's a great question. And this is exactly one of the issues that we are trying to address through the Scientific Software Engineering Center. The way we are addressing this issue right now is at the onset, we create a software requirements document, and then we also create a statement of work. In that statement of work, we work with the PI to identify someone who can be the core maintainer of that software beyond our engagement with it, because we are not in the mode of being able to sustain these software projects beyond helping them build it. And we shouldn't be, because we are not in the sciences we don't really understand, or we are not as deep in the sciences, or not deep at all. Our projects span many, many different scientific domains. So it is important to keep into mind open source community practices. What could be helpful in terms of structuring the project at the very beginning, such that it is set up for success with the open source community. Oftentimes, the PI will have a postdoc, a PhD student who is taking interest in the software, and they can work alongside the engineers who are building the software and be on point to be the core contributor of the software. And we do this, I know you've had some lectures on GitHub and so on. We do this, we also train them on how to do continuous integration, continuous development on GitHub, how to use forks versus branches, and make sure that the research group has the skills required to maintain the project in GitHub. Again, it's something, we are still early in our journey, so it remains to be seen whether we are able to influence a lot of research groups to do this correctly. But because we don't have any incentive in the scientific outcome, our incentive is in making the researchers successful. Our engagement by design is not more than 9 months, maybe 9 months to a year with the project. There's two things we do. One is the identifying the core contributor upfront. The other is to work with them from the very beginning in establishing a community adoption strategy, such that when we exit the project, there has at least been one community adoption event. It could be a workshop, it could be a deployment in a course, in a classroom, in an entire quarter or semester, some kind of setting where we can work alongside them to ensure that the software has been used by a large group of scientists or students or researchers in order to help them set it up for open source. And some of the projects already have open source adoption. We have engineers in our center who have experience in facilitating successful open source adoption practices. And some of them are pretty new. And there are some who may not have already been exposed to why that is important, right? But eventually they get it. So there are multiple tactics that we're using to ensure that the software is going to be sustainable beyond our engagement with it. The learning from the open source community in terms of what strategies work is extremely important when it comes to setting these up. I'm not going to cover those in my talk right now, but we do have plans to do this in September. We have a speaker, and we are starting to look into this because we are at the point with, we have 6 projects right now. We are at the point where we are going into the deployment stage and looking at the customer adoption and the open source adoption of these projects. Does that clarify, Eric, or you have any? Okay, thank you. Thank you for that question. Here's another tool to use in terms of product team management. Once you have that product plan, once you have achieved alignment with your stakeholders, when you are then looking at just your project team, there's something called the RACI framework, which is RACI stands for responsible, accountable, consulted, and informed. Who's responsible for executing the project? Who's accountable? Who do you need to consult, and who do you need to inform as you execute on the project? The older version of RACI was OARP, owner, approver, reviewer, participant. So this is also another one of those concepts that has grown over the years. And these days, people use this RACI framework. This is a very common way of demonstrating what the RACI framework is like. For I'm not super fluent in Lord of the Rings, but for those of you who are, you can see that in pink are the different tasks that are involved in the series, in the epic. And the personas are the different players, Frodo, Sam, and so on. And you can see in each cell against each task, who's being consulted, who's responsible, who's accountable, and who's being informed, right? Does that, for those who know the series well, does that look correct? Informed. So who do you need to inform? So this could be like a stakeholder who's not involved in the day-to-day. Going back to our previous slide, it could be the funder or the contracts manager, or just managing up to, you know, the director of the institute where you under which you're doing the research, and so on. And then if you're not into Lord of the Rings, this is another way of looking at it, right? More from a software project point of view, some of the roles are project executive, project manager, the business analyst, the technical architect, and the application developer, and the list of tasks and who's R, A, C, or I. This is another slide where which enumerates the steps to create a RACI chart. The first step is to identify the project roles, and then the project tasks or deliverables, and then assign the RACI to each role and each task. So basically filling in the cells in the matrix that you saw in the previous two slides, getting alignment with the team, then getting alignment with the core project stakeholders, because this is an important part of your project plan, and it is important to get that alignment with all the stakeholders, not just the ones who are going to be part of your RACI framework, because there could be some stakeholders who are not in your RACI framework at all, and that's okay. And then finally, you have to make it useful. You have to refer back to it and align on who is responsible for what, and you have to keep it updated, because if a new engineer who joins the team looks at your RACI framework and notices there are people on there who aren't even part of the project anymore, it's limited in its utility. It needs to be kept current. So it's important to keep that. If you're planning to use this tool, it is important to keep it current. Any questions about RACI? Do you see this? I know that the teams that you work on are very small, but this is still something that can be applied to small teams. You may not have every single role, or you may not have a fully fleshed out matrix, but it is important. It's an important tool to actually apply stakeholder management, stakeholder alignment, and so on. Okay, so moving on, we are going to go a little bit more into the details of software development lifecycle. We'll talk a little bit about what are the different models under which software is built, and what are the tools that are used today in software development. Give you a second to look at this. Looks familiar? One of the terms we used, we did a workshop earlier this year at SSEEK on the social science practices of research software development. One of the terms that I heard in that workshop from one of the scholars who studies this area is clean Xcode. You write it once and you throw it away, right? I thought that was so interesting, because in academia, oftentimes software gets written for a paper publication, again, going back to the crisis of reproducibility, because there is no regulation, or there is no enforcement of publishing your data and your code along with your paper. Oftentimes the code is just enough to is just good enough to last the lifetime of that paper publication, and then it gets thrown away. right? If you are interested in building software that sustains and that will be helpful to your community and that can outlast the paper publication, it is really important to start with the mindset of, how you're going to do that using some of these techniques. There are two kinds of software development life cycles that are predominant. There's a few others as well. Back in the day, there was this technique called waterfall, where you define the problem, you design it, you develop it, you test it, and then you deploy it to your users. It was like a one and done thing. This is when software was still being shipped in boxes. It was a somewhat clean approach, but there used to be really long idle times. So the ones who are responsible for, say, developing the software aren't necessarily involved when the business is coming up with, the business justification or the software requirements and so on. So there used to be all this idle time, and bugs were extremely expensive to fix, because once the software is in the box and in the shelf, in the market, if you try to recall it, there have been some huge failures there, right? There was the Windows Vista failure. There's been many such failures because bugs are expensive. So you have to be very mindful of this. Now within the services model, it doesn't have to be that way. So software is built using agile methodologies, where it's a constant cycle of define, design, test, deploy. Windows ships updates every single month. Your computers constantly, not just Windows, right? Apple does the same, like Microsoft, Apple, all of these tech companies are constantly shipping updates. If you use a smartwatch, your smartwatch is updating everything. It's got cars now, cars that run on software are constantly updating. So it doesn't have to be this huge, risky business to deploy software anymore. You have the ability to fix bugs because you're shipping software in a services model. So when someone says they're following an agile development methodology, what they mean is they're following this, where they are very agile and responsive to customer feedback, they're responsive to quality issues in the product, and they have the ability and the infrastructure to constantly update their software in response to those. And surprisingly, the history of agile software methodologies is rooted in scientific software, with scientists starting from the 1620s, when Francis Bacon articulated in his scientific method some traces of agile. So it's really cool to see that this is something that has relevance as far as history is concerned in scientific software. It was more recently in the 2000s at Snowbird in Utah that Jeff Sutherland and a team of, I think there were 17 of them, came together and they came up with this agile development Scrum methodology. There was something called the Manifesto for Agile Software Development. And then there was this term called Scrum, and then a term called Kanban that came up as a result of this. And can you see this? It's big enough, right? Yeah, this was a really nice cartoon that I found. I think the original source is up on the right. And it's a really good illustration of how Scrum works. So Scrum is agile. It's not waterfall anymore. It's a constantly updating way of building software. So I'll give you 5 minutes to look at this and digest it. there's two main components of Scrum. One is a product backlog and one is a sprint backlog. The product backlog is based on a set of features that you want to build for the product in response to the user stories. User stories is another term that is very common in software development. User stories, I don't remember if I have a slide about this, but user stories are about listing out all those different kinds of users and thinking about what they will do with the software to what end. So once you've enumerated all of your users' tasks in terms of how they're going to use the software, from that emerges a set of features that your software needs to have that goes into the product backlog. From that product backlog, you can create a set of more granular tasks that goes into a sprint backlog. And then depending on what methodology you're using, whether you're using, oftentimes it's common to use 3-week sprints. In the Scrum methodology, 3-week sprints followed by oftentimes like a 1-week sprint retrospective. They have that over here. You assign those backlog items, the sprint backlog items, into specific individuals who are going to execute on those sprint items. And you do a daily stand-up. I saw that you have stand-up in your hackathon as well. So that's a good time to check in with each other. This is very useful when there are multiple folks working on a project, because if one person is blocked on something, they can bring it to the stand-up, talk about it. Or if someone is overloaded, they can ask for help in the stand-up and so on. The sprint, this kind of a Scrum framework was very popular, I would say in the mid-2000s is when we had started to use it. Over time, it has dwindled a little bit in its popularity, while it was so exciting for it, because it was so different than the traditional waterfall method. It was also leading to burnout. You cannot be sprinting. The reason why, sprints are tiring. If anyone's a long distance runner, you sprint only towards the end of the race. You can't sprint for 13 miles or 26 miles, right? So this was leading to a lot of burnout. So these days, no one really follows the Scrum framework strictly. They follow some variation of it, including in our center. We follow a variation of Scrum, which is kind of between Scrum and Kanban, and I'll come to Kanban in a second. Any questions about Scrum? Yes.
So let's say you're doing a 5-day hackathon.
Yeah.
Does it map well on a sprint? Like you start off, maybe your product backlog is very small, it's just like an idea.
Yes.
And then you plan it out what you'd like to do, and then do it daily, maybe it's 5 days, maybe twice a day, daily Scrum, right?
Yeah. So Ariel's question for the folks on Zoom was, how does this make sense in a 5-day hackathon? That's a great question. And I think it does. You can condense this to whichever time frame that you want. And like you described, you could have, and I have done hackathons in the past where hackathons tend to be intense. I don't know if yours are intense, or it could be, depends on how motivated people are and what the quality of the food is. The way it works in these more compressed timelines is you have multiple stand-ups a day, or oftentimes in hackathons, you're just co-working, right? You're just sitting together. So you don't need to have a scheduled one day, but oftentimes it will be like, let's do a stand-up at 9 a.m. and another one at 4 p.m. to see where we're at, right? Because then if you're stuck on something and you continue to ruminate on it before you start coding again the next day, that's important. But more importantly, this backlog-based approach of planning, estimating. I don't know if this cartoon goes into estimating at all, but when you create that product backlog, and I'll go into some of the tools. Some of the tools actually give you easy ways of, providing some of those details. When you create that product backlog and when you create that sprint backlog, you assign estimates to it. They're called story points. Oftentimes they're in these Fibonacci increments. So it's like 1 day or 2 days or 3 days or 5 days. And if you look at, and because it's very difficult to estimate, oh, that's going to take 7.5 days, or that's going to take, 12 days. But if you think of it in, okay, there's enough unknown about this that's going to be 40 story points, you need to break that into smaller units. So a good rule of thumb is it shouldn't be more than 2, 3, or 5 story points. And again, a lot of this now is on intuition. So if any one of you is an expert on this, I might be saying something that is not by the book, but the way I would do this in a 5-day hackathon is instead of days, I would use hours for those Fibonacci estimates. So I'll be like, okay, that's going to take me an hour to do. That's going to take me 5 hours to do. That's going to take me 40 hours to do. That's the whole week. So you cannot be taking on anything else. It helps you understand whether the scope of what you're about to do is going to fit in the time that you have through that hackathon period. Yes.
To build on that question, what if you're not sure how many hours it will take you? What's the best way to scope it out?
Then it seems like you need to assign a task to do the research that will help you get to that estimate. So if you're saying you don't know how long it's going to take you, it's a large estimate. It's like, say, 13 or 40 hours, right? So what do you need to do to get to a better estimate? You need to do some research. You need to maybe try out that library. You need to see whether it's already been done. And that's going to maybe take you an hour. So you create a task to track that 1 hour, and you make the actual task dependent on this task. And again, the tools have mechanisms for you to do that. And then in the next stand-up, you discuss your findings with your team and brainstorm whether you have enough information now to do the task. You're no longer blocked. Otherwise, that parent task is being blocked by the subtask where you have to do the research to come up with an estimate that is feasible to do in the time frame that you have. Yeah.
At what point do you cut your losses and go for it if you are still not sure?
So the question was, at what point do you cut your losses and go for it, even if you're still not sure? Well, it depends on what your goals are. If your goal is to prototype something, which it should be if it's a hackathon, you're not going to achieve product market fit at the end of the hackathon, then it is okay to think of it as, think of the task as building and testing a prototype, right? But at the same time, you should also think of an alternative, have maybe another option, have someone else on your team also explore an alternative approach, and be okay to go with, at one point, like, so you spend a day on it, don't get attached. Please don't get attached. This is one of the biggest lessons I have learned the hard way in software development. After you have put, I think there's a theory, it's called loss aversion, right? That's the theory for it. Because you have put so much effort into it, it ends up becoming your baby. It's not your baby. It's just a bunch of code, okay? It's just ones and zeros. It's nobody's baby. Don't get attached. Cut your losses, help your teammate. If you feel like that is going to be more successful, become part of that other solution that is likely to be more successful. Don't get attached to software that may not be feasible. Yes.
So you mentioned Fibonacci numbers.
Yes.
3 times in terms of estimate. Where do those come from? And what's the significance of Fibonacci?
Yeah, the significance of Fibonacci is when you are coming up with estimates, and also think about in the software industry, there's layers and layers of middle management that are created to just manage this stuff, right? So at the beginning of the software development process, a program manager will go to the developer and say, okay, this is the feature you need to build. Tell me how long it's going to take, right? And the dev says, oh, this is going to take me 2.5 days. This is going to take me 7 days. There's a estimate, there's a number beyond which that estimate just cannot be accurate, right? And typically that number, if you think of just your day-to-day work or software that you have created, typically that number is maybe like no more than 5 days. You know, this is going to take you 5 days. If it's going to take you more than 5 days, there's enough unknown about it that you cannot accurately estimate it's going to be 7 days or 10 days. So an easy way to solve for that in these tools and all is to come up with Fibonacci estimates. So if the dev says, okay, you know what, it's going to take me, I don't know, I really don't know, stop pressuring me to give you an accurate estimate, right? So then you use the bigger numbers to put estimates against tasks that have so much unknown about them that it's going to take him more than a week to do. And then you help break it down. But for now, as long as the developer, the software developer has tasks on his or her plate or their plate to accomplish in the 1 day, 2 day, 3 day, 5 day, that's enough to keep the productivity going. Because that is important. That is typically in large teams, that is not the estimation and the requirements gathering is not the role of the programmer, which may not be the case here because you're working on really small teams. It's typically not the case in academia. But if you want distraction-free coding time, then you should not be spending too much time on the software requirements gathering. Ideally, there's someone else who's doing that, someone who's dedicated to doing that. It's their job. That's where it came from. Yeah, so in pure Scrum teams, there's actually, if you see the blue circle on the side here, there's actually a Scrum Master whose full-time job, it's typically the program manager for the project, and their full-time job is just to keep this process going and entering things and moving things. And a lot of these tools give you ways to move things around and all. They're actually pretty fun to work with. Because I said, as I said earlier, Scrum was tending to, the pure Scrum model was tending to be a little tiresome since people are just sprinting and sprinting and sprinting. You can't do 6 months worth of development just in these 3-week sprint. It leads to burnout. There was this new concept that came out called Kanban, which is a little different in which you're not necessarily sprinting. You just have a huge backlog of items. And this is more like the traditional waterfall, but not, some people call this the Scrummer fall, where you just have a huge bunch of backlog items and you're taking them out of the backlog. And we are following something like this because we have these 9-month cycles for our projects right now at the center. So we track monthly milestones, and from the monthly milestones, we sometimes track these weekly milestones and so on, right? So again, like these are just all tools and terms, and there's a lot of training, there's a lot of stuff out there for all of these things. You just need to know what these are so that you have some of these tools that you can use for your project management. So let's talk a little bit about the tools that I've been touting. These are the tools that I have personally used in addition to Visual Studio DevOps and some of the more proprietary tools. Have you used these tools? Trello, Asana, Basecamp? Yeah, variations of this, yeah. If you look at many of these tools are integrated with GitHub. And if you go to GitHub and look for project management tools, it's like 1,228 results, right? So there's a ton of them. And it's actually a big business. If all of these companies are in business doing nothing but creating software tools for project management, you can imagine how rich this ecosystem is. And I would say don't get too hung up on the tools, pick one and go with it. Most of these tools, in my experience, are pretty equivalent in, the type of functionality they provide. Just like, when you're creating a PowerPoint deck, I don't know if you've been in this state where you end up spending too much time creating animations and all that and not really think about the content. You can get really hung up with these tools because they're so fun to use. So just pick one and try not to spend too much time on this. This is an example from the Trello website of the cards. And I say fun because there's this very visceral feeling you get when you drag something from in progress to done, right? That's kind of the way to, just like when you have things on a sticky note and you cross it out. Yes, question.
In my experience, my teams have tended to set the board up because it seemed like a good idea, and then just never use it. So can you say anything about, like, maybe we didn't do it? It should be helping you. So if you're not using it, it means we did it wrong. So yeah.
Was the project successful at the end?
Yeah.
Then you probably didn't need it, and that's fine. What other? Okay, so the comment was that. Sorry, your name?
Alisa.
Alisa's comment was that she's been in a team where they set up the board, but they ended up not using it and the project was successful. Even the very exercise of setting up the board clarified software requirements in your head, right? And that itself is useful, which is why I say these tools are there for you to use whatever you want. You don't have to strictly follow it. How long was this project?
A week.
Yeah, so yeah, in a week, unless you have someone whose job it is to maintain the board, it's likely not going to get done, right? And the reason why the board is important is, again, a big part of it is obviously the day-to-day management of the software development process, but another big part is for stakeholder engagement, right? If you show your PI or your, whoever your boss is, your code, it's not as meaningful as you show them a description of what was done and, something that is in English that they can read and they can absorb it, that they can potentially, use when they report out the successes of their group, right? So some of this is just for tracking purposes also, but in a compressed time frame, such as a week-long project, it most likely is just helpful for you to really clarify the software requirements. On the right in this bulleted list are some of the things that these tools provide. It lets you put in due dates, members, checklists, attachments, and comments. And then finally, I have just a few more slides left. So maybe another 5-10 minutes of content, but these are from the projects that we have at the center and I think our first project must have kicked off only in January. We have about 6 now. So most of these projects are, 6 months or so old. We use GitHub for issue tracking. We use ZenHub for project management, and we don't use it very strictly. The reason for that is all of our projects are very independent of each other. So we don't have multiple engineers working on the same project, and most of these tools are optimized for teamwork. They're not optimized for individuals working on different projects. And some of them give you access to different organizations. We ran into some challenges at the beginning because we were trying to track everything under our GitHub organization, but at least a couple of projects were mature enough that they had their own GitHub organization and their own GitHub repository, and it would make more sense for us to contribute there instead of managing our own. And the tools do an okay job of incorporating external organizations into the framework that you're setting up. Yeah, question?
We had a distinction between everyone working same project versus different projects. What about if you have a single project, but it's well modularized, where people are working on very independent parts of it? Would you, in your experience, are these tools helpful?
So the question was, I talked about 2 modes where everyone is working on the same project or everyone is working on different projects. There's a third mode where the project itself is well modularized and the ownership is clearly defined. Does it all come together at the end? That's why it's important, right? It's important if it's well modularized, that's great because you've already developed some tooling or some intuition to be able to do that, right? And these tools also help you do that. When you break a product into the features and then into the tasks, you're modularizing it. But at the end of the day, it all has to come together to create the product that is then useful to your customer, right? So at some point, you need to figure out, how you're going to accomplish that. So is this a project that's still in progress? Yeah, so you have to, depends on what your goals are, right? So if your goals are to end up with a comprehensive product that's going to be successful and adopted by the community, that there needs to be some tracking as to how that will happen. Yeah, but modularization is good. And we do have best practices, readability of code, modular code is important. Pull requests needing to be small, having multiple people review a pull request, not having pull requests that are not attached to an issue. It's important that your pull requests are attached to issues in GitHub so that they can be tracked. All that is really important in software development. Yes.
So you should create an issue first.
Absolutely, yes. Before you create a pull request, you absolutely have to have an issue tracking it. Now, it also depends a little bit on where the accountability lies, right? If the accountability is just with you, if this is some hobby project you're doing, it probably doesn't matter. But if you had to ever revisit the project to determine what code you wrote to accomplish what task, it's really important to have that record of what issues contributed to what code in your code base. So if you look at some of the GitHub best practices, that is one of them. You cannot have pull requests not attached to issues. And then even bugs. And earlier we talked about if you have to do research to determine, more achievable increment estimates of your code. That should also be anything that engineers are spending time on has to be tracked via issues, ideally, so that there is visibility to how, where the time is going. For accountability, for reporting, for stakeholder alignment, and so on. This is just an outline of our software requirement specification. This is a bit old school. The most important aspect of this that I push towards when during the early engagement phase with PIs and software requirements is section 2.3, which is the user personas and characteristics. And this is where the user stories come into place. That's how we got that really comprehensive list of users in our neglected diagnostics project, because we were very thoughtful and we really pushed to create clear user stories so that when the software is ready and the software can be taken to a workshop, the PI is thoughtful about incorporating all of those different groups into that deployment vehicle, into that open source adoption event. Yeah.
What are user stories?
So user story is an articulation of how a user will use a feature in the software to what purpose. And there's a lot about it. Atlassian has done a really good job of documenting. I often show PIs the Atlassian website. Atlassian is the company that has created the software tooling called Jira, which is very common in software development, project management. That articulation of users, of how users will use the software features to achieve what outcome is very important to be comprehensive in coming up with the features that your software needs to have. And when you are working on your hackathon, I would highly encourage you to take at least some time thinking comprehensively about that. So for instance, if you're building some software, you typically will only think about and this is common, this is even common in industry where you only think about the success case, right? You don't think about all the, in responsible AI, there's this term called unintended stakeholders. If, you know, I was working on a little bit on this stuff about a couple of years ago. Unintended stakeholders are users who will end up using your software that you hadn't intended will use your software, right? So is your software going to be harmful, right? If there are unintended stakeholders, that could be, that's kind of one extreme, but there's all these users along the way that you may not think of unless you're thoughtful about your user stories at the onset of your software project. So we use ZenHub, like I said. This is, like I said, we started our project sometime in January. And this is an image, I mean, I like to, and this was, I wasn't necessarily driving towards this, but because all our issues were in GitHub and they were being tracked automatically by ZenHub, you know, we got this nice image of the opened versus closed. And you can see some of the kind of pillars that we created up in the checkbox, right? We actually even create our comms. So even tasks that we have to do on the website. Where's my mouse? So there it is. Right, so even like the tasks that the program manager who recently joined our team has to do to update our website, we track via GitHub, which is important to do so that, you know, there's good load balancing, right? You don't want to overload too much on someone. And especially this happens a lot with junior developers where they will take on more work than they can possibly do. So you have to be careful that that's not happening by asking them for estimates and making sure that you're load balancing across the team. This is another graphic just out of the box that we got. This is a burn down chart. This is for a single sprint. And again, I'm not very strict in how, you know, we track this because the last thing you want is, you know, spending too much time trying to implement these processes. But you can see that there are 121 completed story points. 121 completed story points, 64 remaining. And then you can see the issues and pull requests also. And you can see in the white dashed line is the ideal burn down chart. If the blue line, and the reason why it's so like step function is because we don't have estimates against all of our tasks, and that's something that we'll fix as we go. My way of measuring things are getting done is we have monthly milestones in our statement of work, and I check in to see that those monthly milestones are being met. You can see that there are these, there's a lot that happens on, I think that's a Monday, right? Because a lot of, possibly a lot of, you know, code got checked in, a lot of issues got closed and so on, right? So some of this is working. And again, like it drives accountability, drives visibility. And then this is another out of the box chart that we got. In this, it didn't let me select, this is still in beta for ZenHub. So, and again, by no means am I, you know, advocating to use ZenHub. It just happens to be something we use. We do have a paid license for it. The reason we use ZenHub and didn't just go with GitHub projects is because at least when I was looking at this 6-8 months ago, GitHub projects was not giving me a way to put in estimates for issues. I think they're going to build that feature, but as of at least a few months ago, they were not doing that. So just for that, I decided to use an external tool that could pull our GitHub issues where I could set estimates and track issues like this. The reason why this is a bit inconsistent with the previous slide is because this is not letting me select the star repos. Remember, I said that some of the repositories we contribute to are external to our organization, right? So when I do these reports, I have to make sure that I only select the ones that are within our organization. but sometimes it doesn't really comprehensively capture all of the work, which is okay. So none of these tools are perfect, but they give you some visibility to what's going on. So that was kind of my last slide in the talk. This is some additional resources. Like I said, the Atlassian's website does a really good job of describing the different terms that you can use. Rate Your Project is something that we learned about in that workshop. It's rateyourproject.org. It's a self-assessment tool for improving software practices. It's really helpful if you have like an ongoing project or at the onset of your project. LinkedIn Learning has a ton of courses on agile software development processes. So you can go into LinkedIn Learning and look at some of those courses as well. That was my last slide. Any other questions? Or any questions? Yeah.
I'm curious if there are things that stand out to you as common sort of traps or pitfalls early on in project management. Things that folks tend to do wrong when they're starting out.
Yeah. So the question was, are there any common traps or pitfalls in project management? The biggest pitfall in project management is estimation. Oftentimes people estimate, they're very optimistic with their estimates. There's two things, like one is like getting really attached to a particular solution or a particular approach or a particular library because you're familiar with it and not really expanding to exploring what else is out there, especially if you haven't really done that research in a while, right? If you were using something, like if you ask me, I'll be like, yeah, C is the best programming language, but like no one's going to give me a job if I say I want to program in C, because no one programs in C as much anymore, right? It's now mostly much more modern programming languages. So it's estimation where you can be optimistic and you can say, yeah, I think I can do this in one day. Typically in industry, devs, when they estimate, they do a 2x. That's how off it can be. Because if your code doesn't merge, it runs into merge conflicts, or if you just get stuck, or if you fall sick, there's so many things that can happen, right? You don't just consider the amount of time it's going to take you to write the code. You have to take into account the amount of time it's going to take you to merge that code to ensure that it meets all the quality guidelines. Not thinking about tests. What is your testing framework like? Are you thinking about all the unit tests? Are you thinking about all the integration tests, which is really hard to do? Writing integration tests or coming up with, a solution to how you're going to implement your integration tests is extremely hard to do. So ensuring the quality of your software and ensuring that you budget for it. You are writing up tasks to budget for building out the quality of your software is another pitfall. Those are, I think, the biggest ones. Making, the wrong architectural decision can also be pretty fatal as far as software development is concerned. And we had this with one of our projects where the entire premise of what the solution architecture was going to be was flawed. And we spent maybe, 3 months trying to make it work. And then once that solution, the interesting thing was it was based on what the PI had available as a resource, because they had been given some credits to use this solution architecture. It was basically a platform. We had never heard of this platform, but we went with it because it was in the original proposal and it seemed like we didn't have a choice. We should have gone with our gut and said, we don't know how to use this. We haven't seen anything working on this platform. Perhaps we should follow an alternate approach. That alternative approach took 2 weeks to implement. Okay, and it's up and running now. So it was like 3 months of wasted time and 2 weeks to get to the correct solution, right? So making that decision too early on or not really trusting, and this is kind of the opposite of being too attached to a solution. If you actually have experience that your gut tells you that this is probably not the right solution architecture or this is not the right platform choice, and we need to think of something else that we know for sure will work. A lot of times proprietary, you have to look at how big the community is behind a platform, whether it's open or not. What is the sustainability story? I've even had people come up to me and say, hey, this solution or this platform that we're taking a dependency on is owned by a company that seems like they're running out of money. We don't even know if they're going to be in business a year from now. Do we really need to take this dependency, right? So those decisions are also important. Any other questions?
All right, fantastic. Thanks a lot, Vani.
Yeah.